Welcome and good morning to everyone. This is the e-content presentation for the subject of mechanics of fluids under the topic of fluids and its properties. Myself, Dr. S. Vivek, Assistant Professor of Civil Engineering Department, Hindustan College of Engineering and Technology, Coimbatore. First of all, I would like to say what is fluid. A fluid is a substance which is having the liquid or gaseous phase, which means fluid is equal to liquid plus gaseous components. A solid, which is a product or material, can resist applied shear stress by deforming. The basic distinction between the solids and fluids should be very important one. On part of that, a solid can resist an applied shear stress by deforming. A fluid deforms continuously under the influence of shear stress, no matter how the shear stress quantity is it. In solids as well as, stress is also proportional to the strain, but in fluids, stress is proportional to strain rate. Whereas, when a constant shear force is applied, a solid eventually stops deforming at some fixed strain angle, whereas fluid never stops deforming approaches a constant rate of strain. This is what the fluid is, differentiation and distinction between the solids and fluid. You can see that the distinction between the solids and fluids. The solids, the first one, you can see that it is a highly closed molecules. That is, a molecular momentum transfers are very tight and one. In liquid particles, you can see that here also the molecular momentum molecules are highly closed, but not very highly closed. And gaseous particles, you can see the molecular momentum transfers are very far away. Now we have different types of fluids. So that we have to look into here. Fluid also may be defined as a substance which is capable of flowing. It has no shape on its own, but conforms to the shape of following available vessels, which means there are two types of fluids we used to say, ideal and real fluid. Ideal fluids are the fluids which has no viscosity and surface tension, and they are always incompressible. As for ideal fluids, no resistance is also encountered as the fluid moves. However, in nature, the ideal fluids does not exist, and therefore these are the only imaginary fluids so far we consider. And the next one is real fluid. Real fluids are those fluids which are available in the nature naturally. These fluids possess some viscosities, surface tension and compressibility. Therefore, a certain amount of resistance is always offered by these fluids when they are set in motion. You can see that fluids can flow from place to place. Their density can change from place to place if they are incompressible. For example, gases. Fluids are pushed around by pressure forces. An object immersed in a fluid also experiences a buoyancy forces. Now, the basic topic we quoted is fluids and its properties. There are different types of properties are there. Different types of characters of fluids are there. Now we are going to discuss about the physical properties of the fluids. They are density, specific weight, specific gravity, specific volume, viscosity, surface tension, capillarity, and vapor pressure. The first physical property is density or mass density. Density of a fluid normally refers to the density of the fluid particles in a given volume. Simply, I used to say mass per unit volume. That is called density of the fluid. It is a Greek alphabet. The symbol is rho. The density formula is mass per unit volume, and the unit is kilogram per meter cube. The density of the fluid is the concentration of a mass, absolutely. Density is equal to mass by volume, that is a rho is equal to mass by volume, and unit are kg per meter cube. Normally, density of liquid is 1000 kg per meter cube. The next one is specific weight or weight density. You know that every object in the earth is attracted by earth towards its center with an acceleration. That is called acceleration due to gravity, which is equal to 981 centimeter per second square or 9.81 meter per second square. Fluid presence on the earth cannot be exceptions. Every fluid is attracted by the earth, and therefore every fluid has its own weight. Specific weight is defined as the weight of the unit volume of a fluid. Simply the difference I can say, density means mass by volume of the fluid, weight density means weight by volume of the fluid. Here the weight density is denoted by Greek alphabet, that is a gamma. So specific weight formula, which is equal to gamma, is equal to weight of the fluid divided by volume of the fluid. So specific weight of the water value is 9.81 into 10 to the power of 3 Newton per meter cube. So normally this one also stated that gamma is equal to, or specific weight or weight density is equal to rho g. It is also applicable. The next one is specific volume. Specific volume of a fluid is the volume occupied by a unit mass of the fluid. It is also the same as the volume occupied by a unit weight of the fluid. It can be calculated as the volume of the fluid divided by the mass or weight present in that volume. There is no general notation for the specific volume is available, but we denote it as a Greek alphabet. It is a symbol of specific volume. It is also called as reciprocal of density. So specific volume is equal to reciprocal of density, so that the formula is volume per unit mass. So the SI unit of specific volume is meter cube per kg. Then the next property is specific gravity. Originally it was a specific gravity, but later in a physics it is termed as relative density. In engineering, still it is used as a specific gravity. Specific gravity is required for each product available on the earth. It is defined as the ratio of mass of a given volume of a substance to the mass of an equal volume of water at a temperature of 4 degrees Celsius. For gases, the standard fluid is hydrogen or air at a specific temperature and pressure. Specific gravity is generally denoted by capital S. The formula for the specific gravity is that S is equal to density of the fluid divided by density of standard fluid, or specific weight of the fluid divided by specific weight of the standard fluid. Specific gravity of water, which means H2O, the value is 1. Specific gravity for the mercury, Hg, is 13.6. So I hope that I have covered some of the basic properties of the fluids, and remaining properties will be discussed in the upcoming presentations. So I hope everyone have been understood. Thank you all.